Okay, welcome to DT tutorial. In this video, we'll be looking at methane. The chemical formula of methane is CH4. Chemically, it contains 4 atoms of hydrogen and 1 atom of carbon. Methane is an example of a saturated hydrocarbon, and we've established this in the previous class, that a saturated hydrocarbon is a hydrocarbon that contains only single bonds. And being a hydrocarbon, it means that it contains only 2 elements, hydrogen and carbon. These are the 2 elements in a hydrocarbon. And being a saturated hydrocarbon, it simply means that it contains only single bond. So structurally, the methane is like this. It contains 1 carbon with 4 bonds, 4 hydrogen bonds attached to it, to that carbon. So this is the structure of methane. So as you can see vividly here, it contains only single bonds, and that is why it is called a saturated hydrocarbon, because also it contains only 2 elements, carbon and hydrogen. So methane is a typical example of a saturated hydrocarbon, and it is the first and the simplest member of the alkane series. We've already looked at that, and being the first member, it is a gas. Remember, we said in the last class that the first 4 members are gases. So being among the first members, it simply means that methane is a gas. So it's the first and the simplest member of the alkane series. This is very important. It can also come in an exam, that the first and the simplest member of the alkane series is what? You should know that it is methane. So having known all this, let's look at the laboratory preparation of methane. How is methane prepared in the lab? In the lab, methane is prepared by the reaction of sodium ethanoate with soda lime. It is prepared by reaction of sodium ethanoate with soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide. So this compound here, soda lime, is a mixture of these 2 compounds, so sodium hydroxide and calcium oxide. So in the lab, methane is prepared by reaction of sodium ethanoate with soda lime, and I've already said that soda lime is a mixture of sodium hydroxide and calcium oxide. So this is very important too. It can come in an exam. That which of the following is a constituent of soda lime? It is sodium hydroxide and calcium oxide. Sodium hydroxide, calcium oxide, a mixture of them will give you what is called soda lime. So this is very important. Okay, so when sodium ethanoate reacts with soda lime, you will have methane and sodium triazocarbon 4. But in this reaction, in this equation, just know that the reacting species here from this soda lime is sodium hydroxide. There is a reason why soda lime is used rather than using sodium hydroxide alone, but the reacting species here, what will take part in the reaction is sodium hydroxide. The calcium oxide will not take part in the reaction, but this soda lime, which is a mixture of sodium hydroxide and calcium oxide, is preferred in the reaction, and there is a reason for it. We'll look at it as we progress further. So just know here that methane can be prepared in the lab by reaction of sodium ethanoate with soda lime, and know this equation. So this is a setup for the laboratory preparation of methane. Like I've said, it is prepared by heating a mixture of sodium ethanoate and soda lime. So this is the sodium ethanoate and soda lime which are put into this part of the setup, and when they are heated, methane will be produced. As methane is produced, another compound is also produced, sodium triazocarbon 4. So don't forget that. So sodium tries to come before and methane is produced. So methane as a gas will just flow down this part of the setup and it will move up. It will be collected over water and it will go up. So the methane that is produced will be deposited in this part, methane. So methane will be collected here over water. There is a reason why methane is collected over water, and the reason is because methane is highly inflammable and can form explosive mixture with air. So because of the fact that it is highly flammable, it can catch fire easily, it can form explosive mixture with air. That is why it is collected over water, so that the water can kind of dilute that effect. So this is very important. You can be asked in an exam, why is methane collected over water? Or the question can be asked this way: in the laboratory preparation of methane, why is methane collected over water? So methane is collected over water because it is highly inflammable and can form explosive mixture with air. So this is very vital. So like I've said, the reason why methane is collected over water in the laboratory preparation of methane is because methane is highly inflammable and can form explosive mixture with air. So this is very important, so that the water can dilute its highly inflammable effect. So this is very vital. So in the lab, like I've said, methane is prepared by the reaction of sodium ethanoate and soda lime. So when the mixture of sodium ethanoate and soda lime is heated, sodium triacylglycerol 4 is produced and also methane is produced. So the methane as a gas will flow down this tube down and it will be collected over water, and you have methane here. And there is a reason methane is collected over water. We've already established that. It is because methane is highly inflammable and can form explosive mixture with air. So to prevent that effect, it will be collected over water, so that the water will dilute the effect of that inflammation. So back to our equation of the preparation of methane. So this is the equation. The equation is the reaction of sodium ethanoate and soda lime. So like I said, soda lime is a mixture of sodium hydroxide and calcium oxide. So, and what is taking part in the reaction is not the soda lime, but it is the sodium hydroxide. The calcium oxide is not taking part in the reaction, but we use this soda lime, which is a mixture of this and this. But what is actually taking part in the reaction is the sodium hydroxide. So the reason why soda lime is preferred in preference to this sodium hydroxide in the preparation of methane is because this soda lime is not deliquescent. So, no, a deliquescent substance is a substance that will absorb water from the surrounding environment and dissolve in it. So, if you use only sodium hydroxide, it will absorb water from the surrounding environment and dissolve in it, and that will interfere with the production of methane. That will interfere with the reaction. So that is why we use soda lime, because soda lime is not deliquescent. This compound, sodium hydroxide, it is a deliquescent substance. So the reason why soda lime is used in preference to caustic soda, which is sodium hydroxide, another name for sodium hydroxide is caustic soda. So the reason why soda lime is used in preference to sodium hydroxide is because of two main reasons. One is because it is not deliquescent. Soda lime is not deliquescent, and soda lime will not attack the glass. So these are the two major reasons. It can come in an exam. Why is soda lime used in preference to caustic soda in the preparation of methane? It is because it is not deliquescent, and it is because it does not attack the glass. So this is very important. Okay, with this we are done with this class. In the next video we'll look at the chemical reactions of methane.